Now here I'm in a brand new Go project again, in a brand new Go module, and in there I'll add a new file, pointers.go. And in this file, I simply want to introduce you to pointers. We'll build more useful demo applications with pointers and some other features later. Here, we'll just get started with pointers. And for that, I'll of course add this file to the main package and add this main function, which we always need. And here we can pick up that example from the slide and, for example, add a age variable. So that's now a regular variable, not a pointer, just a normal variable. And this value, 32, now would be stored somewhere in memory, but we don't see its address here and we don't need it. We can now work with that variable, for example, by importing the FMT package and outputting it, so that we say age, and then output the age variable. And we could add some function like get adult years, where we maybe want an age of type int as an input, and where we then return age minus 18, so that we get the number of our adult years. Of course, if we are returning a value here, we also have to add that return type here. And now we could also, of course, output the result of calling getAdultYears. We can do this all in one step here, or alternatively, of course, create a new helper variable, adultYears, which is set equal to the return value of getAdultYears, to which we pass the age, so that we can then output adult years. And this all, of course, is pretty standard Go code. If we run this application, we see our age and then the number of years since we turned 18. But now here we have code where we're passing a variable, the age variable, as an argument to various functions, to the println function and the getAdultYears function. And as mentioned, this will lead to a copy being created. So the age received here in getAdultYears will technically not be exactly the same number as we set up here. Instead, it will be a copy of that number. The same value, of course, still 32, but stored in a different place in memory, so that we have the number 32 stored in memory twice. And once this function is done, so after this line of code here, Go's garbage collector will eventually become active and delete that second 32 in memory. That's how this will work. Now let's take a look at how this changes if we're using pointers.